Hello viewers, in today's lecture we are going to study about the applications of integrals. Viewers, here we will take the simple application of integrals, that is area under simple curves, right? So here we have x-axis and y-axis, and let we have a curve y is equal to fx. Suppose this is a simple curve. So y is equal to fx is the equation of a simple curve, and the curve is represented by SR. Clear? Okay. Now suppose we have to find this area, that is our aim is to find the area P, Q, R and S. P, Q, R, S. That is the area bounded by first the curve and this line x is equal to a line, and this is x equal to a line, this is x equal to b line, and x-axis, right? The equation of x-axis is y is equal to 0. Clear? So our aim is to find the area under simple curves, and to do this thing we have the equation of a curve y equal to fx, and our aim is to find the area this PQRS, that is we have to find this area, right? Okay, so here we will make use of a definite integral, right? Here we will make use of definite integral, and for determining this area what we will do, we will divide this entire area, will divide this entire area into small areas, right? Small areas, and these areas are rectangles, right? These small areas are rectangles. How? Let us draw a rectangle like this. Clear? Okay, so here we are taking a very small rectangular area of this whole area, that is PQRS, right? See the rectangle, it looks like this. Clear? Okay, so this is the small rectangular area, and this is known as elementary strip. This is known as elementary strip, right? Okay, now see the width of this rectangle, the width of this rectangle is this length, right? And the height is say y. Clear? And the width is say dx. So width is dx, and the height of this rectangular area, or which is also known as the elementary strip, is y. Clear? So we know that the area of rectangle is length into breadth, right? So what is the area of this rectangle? this rectangle. So this is the width and this is the height. So for width we have dx, and for the length or the height we have y. So we have y dx as the area of this elementary strips. Clear? Now what we will do, now this entire area, that is this area PQRS, will be now divided into such elementary strip, right? And now we'll make use of the concept of definite integral. So the area of this elementary strip is y dx, and let us denote this area by dA. Clear? So this is a small area, this is a small area, and when we divide this region PQRS into such infinitely many such small areas or such small rectangles, then if we take the sum of all those areas of elementary strips, then we get the total area of this region, that is PQRS, right? So now the area of the region PQRS is the sum of the areas of all the elementary strips, right? We will draw another strip like this, we have a strip like this, okay, then we will have the strip like this, and we will go on making such elementary strips. So the area of this region PQRS is, we will integrate from x equal to a to x equal to b, and we will write here dA. Clear? So this area is now written as from a to b, and for dA we will write y dx. Clear? So this is the area of the region, area of region PQRS. Clear? So this is the concept of finding the area under simple curves. Now viewers, I am solving some problems here to illustrate this concept. Now viewers, let us take the second situation. Suppose the curve is plotted like this, and we have to find the area bounded by this curve, that is y equal to fx, and then we have this line which is parallel to x-axis, and the line is given by y is equal to a, and this line, that is y is equal to b, and the y-axis, right? The y-axis, the equation of y-axis is at x equal to 0, right? So if we have to find the area bounded by these four curves, and the bounded area is area PQRS, right? Then what we will do, will again divide this area. This is the area which we have to find, and now what we will do, we will again divide this area into small rectangles, and suppose one such rectangle is this, right? Clear? So the rectangle, it looks like this. This is the rectangle. Clear? Now we see that the width of this is the width, and this is the height of the rectangle, or the length of the rectangle. Clear? So we have divided this area, bounded area, into infinitely many such small rectangles, and for obtaining the area of this region PQRS, we'll find the sum of the areas of all such rectangles. And for finding the sum, what we will do, we'll make use of the concept of integration, definite integral, right? So the concept of definite integral is used to find the area PQRS. So one such rectangle is this, and this rectangle is known as I have just said, it is known as the elementary strip. Clear? This is known as the elementary strip, and the height is x and the width is dy. Clear? So the width is dy and height is x. So the area of this elementary strip is area of elementary strip is length into breadth, right? Now what is length? Length is the height, and length is x, and the breadth or the width is dy, right? So we have this small area or elementary area, which is denoted by dA, is equal to x dy, right? Now to find this entire area, what we have to do, we have to integrate this area from a to b. So we'll integrate it from y is equal to a to y is equal to b, and here we'll write dA. Clear? So this area, this whole area is equal to from a to b, and for dA we will write x dy. Clear? So when the elementary strips are parallel to x-axis, then the area is obtained like this, from a to b and x dy, when the elementary strips are parallel to x-axis. And in the introduction part, we have taken the elementary strips parallel to y-axis, and in that case the area is given by from a to b, and we have y dx, right? So we can take any of the two methods, but the commonly used method is this one, in which we take the elementary strips parallel to x-axis, right? Sorry, it is parallel to y-axis. Clear? And here the elementary strips are parallel to x-axis, right? Okay, so here's the main objective of this lecture is to find the area of bounded regions, right? And in solving problems, we will come across with different equations, and we will see how to utilize this concept in finding the areas of bounded regions. So let us take a very simple problem, how to utilize this concept. Now viewers, this is a very simple problem and very conceptual problem. here we have to find the area of the region bounded by the curve y square is equal to x. So first of all, our aim is to identify the curves which are given in the question. So we have y square is equal to x, and we know that this is the equation of a parabola, right? Okay, so the first aim is to identify the curves. So here we have y square is equal to x, and this is a parabola, and the lines x equal to 1 is the line which is parallel to y axis, x is equal to 4 is again a line which is parallel to y axis and the x axis, right? And the x axis, and the equation of x axis is y is equal to 0. The equation is not given here, so it is our in our part that we should identify the equation of the curves. So here x axis is given, so the equation of x axis is y is equal to 0. So I am once again reading this question. Find the area of the region bounded by the curve y square is equal to x and the lines x equal to 1, x equal to 4 and the x axis in the first quadrant, right? So thus the next aim is to plot the rough sketch of all these curves, right? So here we have the coordinate system, and see y square is equal to x. Now here we'll plot or we'll sketch this parabola. So we know that the shape of y square is equal to 4ax, right? This is of the form y square is equal to 4ax. So the shape of this curve is like this. Clear? Okay. Now we have plotted this curve. Now x equal to 1. So this is 0, and say here we have 1, here we have 2, here we have 3, here we have 4, and so on. Now x equal to 1 is a line which is parallel to y axis. Clear? So we have this line, right? So here we have the line. So here we have 1, and this is x equal to 1 line, and this is y square is equal to x. Now the second line is x equal to 4. So the line is like this. So here we have this is x equal to 4, right? Now we have plotted y square is equal to x, x equal to 1 is this line, x equal to 4 is this line, and y is equal to 0 is the x axis, right? So this is y equal to 0. Now viewers, here we have to note one thing, that we have to find the area of the region which is bounded by the curve y square equal to x and the lines x equal to 1, x equal to 4 and the x axis in the first quadrant, right? So what we will do, we will take the area above this x axis which lies in the first quadrant. So this is the first quadrant. So the required area is this. Clear? Which is bounded by this curve, this curve, this curve and this curve. So we have to find this area, right? So what we will do now, once we have made the rough sketch of all this information, Now we will draw the elementary strip, right? So this is the elementary strip. Okay. Now we know that the area of this region, and let us denote it by P Q R S, right? So the area P Q R S, the shaded area, is given by A to B y dx, right? We have seen in the introduction part that the area is given by this definite integral, that is from a to b y dx. Now here the value of a is 1 and the value of b is 4, right? And the value of y will be taken from the equation of parabola, right? So the value of y is square root of x. Clear? Because y square is x, so y is equal to square root of x. Now we substitute this value in this integral. Clear? So the area is, now this area A is from 1 to 4, and then we have y. For y we have square root of x, and here we have dx. Now this becomes a very simple definite integral. The integral of x raised to half is 3 by 2, and here we will have 2 by 3. And now we will have the limits here. Clear? So 2 by 3, x raised to 3 by 2. This is the indefinite integral of square root of x. Now we will simply use the concept of evaluating the definite integral. So we have 2 by 3, and now we will substitute here 4. This is 4 raised to 3 by 2, and then minus 1 raised to 3 by 2. Clear? Now this is 2 by 3, and 4 raised to 3 by 2 is 8, right? Okay, and 1 raised to 3 by 2 is simply 1. So we have 7 to the 14, so we have 14 by 3. So this is the required value of the area of this shaded region. Clear? Okay, here we can write y also, and this is dx. Clear? So the area of this elementary strip is y dx, and when we will integrate all such strips, all such elementary strips from x equal to 1, that is from a is equal to 1 to b is equal to 4, right? So we will have the value of area as 14 by 3. Now viewers, let us take this problem. Find the area bounded by the curve y equal to sin x between x equal to 0 and x equal to 2 pi. So here the equation of the curve is given as y is equal to sin x, right? And we have to find the area bounded by this curve between 0, x equal to 0 and x equal to 2 pi. So viewers, let us first plot the graph of y is equal to sin x. Clear? Okay, so we know that the graph of y equal to sin x, it looks like this. See, we have the curve, the equation of the curve is y equal to sin x. So the plot of, or the graph of y equal to sin x, it looks like this. Here we have 0, here we have pi, here we have 2 pi, right? And here we have plus 1, and here we have minus 1. Clear? So our aim is to find the area from this point to this point. Clear? So it means we have to add these two areas, or in other words we can say that if we find the area of one part, then we can double it to find the entire area. So here the required area can be written as 2 times of the area from 0 to pi, right? From 0 to pi. And we'll draw the elementary strip. So this is y, this is dx. So we write here y times of dx. Clear? Because we know that the area is given by a to b y dx. Clear? So we are finding the area, this area, and in order to get the entire area we are multiplying it by 2. Okay, so we have 2. This is from 0 to pi, and y dx. So y is equal to sin x. So here we'll write sin x and dx. Now this becomes a very simple problem of definite integrals. So the integral of sin x is minus cos x, and we have 0 to pi. Now this is minus 2, taking negative sign outside, we have cos x 0 to pi, and now this can be written as cos of pi minus cos of 0, and here we have cos pi is minus 1, cos 0 is 1, so we have 1. So this is minus 2 times minus 2, and this is plus 4, right? So the area from 0 to 2 pi is 4, right? Now viewers, here we have to find the area bounded by the curve y square is equal to 4x and the line x equal to 4. So here the equation of the curve is given as y square is equal to 4x, which is a parabola, and the other curve is x equal to 4, and this is a line, right? Now what we will do, we will plot, or we will draw a rough sketch of these two curves, and here we have y square is equal to 4x is the parabola like this, and x equal to 4 is the line. See, here we have 0, here we have 1, here we have 2, here we have 3, and here we have 4. So the line x equal to 4 is like this, and our aim is to find this area, right? We have to find this shaded area. This is the region, right? Suppose we were given that find the area bounded by the curve y square is equal to 4x and the line x equal to 4 above x-axis, then we have to find only this area, but here this condition is not given, so we'll find this upper area and then we'll multiply it by 2, right? So this is x equal to 4 line, and this is y square equal to 4x, and let us draw the strip, the elementary strip. See, this is the elementary strip, right? So the width is dx and the height is y. Clear? Okay, so the required area is now given by 2 times, right? Because we have to find the entire area. So we are finding the upper area, that is this area, or we can denote it like this. Say this is P, this is Q, and this is R. So we are finding the area OPQ, and then we'll multiply it by 2. So the required area is 2 times of the integral from 0 to 4, and here we have y dx. Clear? Now this is 2 times of 0 to 4, and the value of y will be calculated from this expression. So this is square root of 4x, square root of 4x dx. Clear? Now we have 2 times square root of 4 is 2, so we have 0 to 4 square root of x dx. Clear? So this is 4, and 2 to the 4, and the integral of x raised to half is 2 by 3, x raised to 3 by 2, and we have from 0 to 4. Now this can be written as 4 times 2 by 3. We have x raised to 3 by 2 from 0 to 4. This is 8 by 3, and we have 4 raised to 3 by 2 minus 0. Clear? And this can be simplified as 8 by 3, and this can be written as 2 square, or we can write it as 8, because 4 raised to 3 by 2 is 2 square 3 by 2, and 2 get cancelled, so we have 2 raised to 3, that is 8. So this is 8 just 64 by 3, right? So viewers, this area, this shaded area, is equal to 64 by 3 square units.